Hey guys, in this video I'm just going to cover the very basics of bearings. Nothing too tricky, but the first thing you need to know is with what a bearing is, it's just a way that we describe which direction that we're traveling. And when I do it, I always think if you're looking from above, it's which way do I need to face, or which way would I need to turn my body in order to face the right direction that I want to go. So with your bearings, when you're reading them, you always have to start from north. So you need to start from north, and the bearing, it's always the angle going around clockwise. So for most of these questions, you're going to have a starting position, and you'll normally be given your north, south, east, and west, but if you're not, you'll need to draw them in. And you're going to be given some information of where you're traveling, and it'll probably give you an angle, or you might have to find the angle. So basically what we're going to be trying to find is the angle that we need to go. Now, there's a couple of things, or a couple of tips that you need to do. First thing is that you need to draw the 4 compass directions at each point. So it could be where you started, where you stopped, could be a place that you ended up visiting in between somehow. So most of the time you're only going to be doing 2 points, but sometimes you'll be doing 3 or 4. So first thing you want to do for all these questions is draw in your compass, and you got your north, your south, your east, and your west. And then we could fill in any directions that we had as well, and any angles, and same again for where we're finishing. We've got north, south, east, and west. And once we actually fill in all these different parts, then it's usually fairly easy to complete the rest of the question. Now, another thing, I guess a tool if you wish, that you need to do or look for is for your alternate angles. And what your alternate angles are is if you have parallel lines, it's these Z's where the 2 angles that are formed between your parallel lines and this line are equal. So this angle here is the same as that angle there. And for bearings, you use these all the time. Now, where these parallel lines come from is your north, south, east, and west. So if I've got 2 points, so I've got my A and my B again, you can see that there's a Z from here down to here, which means that this angle and this angle are exactly the same. And there's also another tricky Z going this way. So it's side on, but you've got this Z formation here. So what that means is this angle is the same as that angle as well. And more often than not, you're going to need to fill all these angles in, or you'll be given one of them. I guess we'll see when we do a couple of examples. But main thing is look for your alternate angles. Alright, so this is your sort of classic style question. You're going to be given 2 points. O is usually the origin, so it's where you start from, and we just got another point, which in this case is A. So for the first one, we want to find the bearing of A from O. So we want to know what direction, what angle do I need to twist my body in order to get to A if I start at O. So this one's fairly simple. Remember, you have to start from north, going around clockwise, so it's just the angle from here to here. And luckily, they've actually already told me that it's 40 degrees just from there to there. So the bearing to get from A to O, the bearing is going to equal, and you have to write 0 because it needs to be 3 digits, 0 for 0 degrees. You usually put a little T for true, for your true bearing. So the first one's easy. The next one, we want to find the bearing of O from A. So if we are at A, we want to find out what angle do I need, or what bearing do I need to travel on to get to O. So it's a little bit harder to see right now, but if I put in my north, south, east, and west, so I've got north, south, east, and west. From this point here, I need to find the angle from north all the way around here until I get to the line that goes back to O. So I want to find out this angle all the way around. Now, between north and south, it's 90 degrees to get from north to east, and it's another 90 degrees to get from east to south, so it's 180 degrees from here to here. What I need to know is I need to find out what this little guy is here, and I'll add it to the 180, and that's the bearing I'm going to need to travel on. Now, if you have a look, hopefully you can see the Z. So there's a Z going from here, down, up, and here, which means that this angle here is the same as that 40 degrees there. So this little guy in here, it's 40 degrees. So the bearing from north to south, that's 180 degrees, straight line. It's going to be 180 plus 40. So I'm just going to write down here, it's 180 degrees plus 40 degrees. That's going to give me 220 degrees. So the angle from here all the way around, 220 degrees. So the bearing, it's going to be equal to 220 degrees. It's the true bearing. Alright, let's have a look at a couple of others. Alright, for this one, same thing. We've got a point. We start at O, and we've got point A. We want to find the bearing of A from O. Now, it doesn't actually give us an angle here, so I'm just going to fill one in. Let's just pretend that this was 20 degrees. So, if we're going to A from O, we're starting at O. We want the angle from here going all the way around to here. So, it's 180 degrees from here to here, and then we've just got an additional 20 degrees. So, the bearing from A to O is going to be 180 degrees plus 20 degrees, which is equal to 200 degrees true north. So the answer for I, the bearing is 200 degrees true north. Alright, for I, what we want to do is then we're starting at A and we want to go back to O. So what I need to do first is draw in my north, south, east, and west. And I've got north, south, east, west. So I'm starting here. I want the angle that I need to face in order to travel in this direction. So it's the angle from north going clockwise, so it's just from here to here. Now again, hopefully you can see the Z. So down here, up here, down here, which is 20 degrees. So the angle from O to A, the bearing is just this angle here, which is 20 degrees. So the bearing is 20, oh, got to put the 0 in front. So 0 to 0 degrees, that's my bearing. Right, let's do one that's a little bit harder. We've got a bit more information. So we've got a fishing boat travels from a harbour. So I've got the harbour over here, and it's travelling on a bearing of 140 degrees. So 140 degrees is from here all the way around to down here. And it's travelling for 60 kilometres until it reaches an island. So it's travelling along this line for 60 kilometres, which doesn't say, so I'm going to write that in. So it's 60 kilometres. Now, what I want to find is how far due east does it travel. Now, due east means how far in the exactly east direction. So how far directly east has it travelled once it reaches this point here. So what I'm going to do is I'm just going to extend that line out to about there, and I'm going to draw a, oh, I forgot to put my compass points in. So I've got my north, south, east, and west. And what I'm going to do is I need to form a triangle so that you can use your trigonometric ratios. So if I extend that up, I'll form a right angle there. So I want to find out how far east. So I want to find out when he ends up down here, how far just in this direction has he gone. So I want to find out this length from here all the way to here. Now, in order to use my trigonometric ratios, I need to have either this angle here or this angle down here. Now, I have no information about this one down here, so I'm going to try to look up this way. Now, it's 140 degrees from here down to here, but I know that there's a right angle here, so it's 90 degrees to go from north to east. So this little guy in here, it's going to be, so just from there to there, that angle there is going to be the 140 degrees. Take away this right angle is going to leave me with this bit. So that means that this guy in here is going to be 50 degrees. So then what I need to do is try and decide which ratio I want to use. So I've got an angle. I know that this is 60. That's going to be my hypotenuse, because my right angle's up there. And this side, because I'm using this angle, the 50, this is going to be my adjacent. So I've got an adjacent hypotenuse. I'm going to be using cos theta. So it's cos theta equals adjacent divided by hypotenuse. And I'm going to sub everything in. So my angle is 50 degrees. So it's cos 50 degrees equals adjacent, which I've called x, divided by my hypotenuse, which is 60. And then all I need to do is multiply this side by 60. So it's going to be 60 cos 50 equals x. And when I throw that in my calculator, it's going to be 60 times cos 50. And I get 38.567. So x is equal to 38.567 8.567 kilometers, and I've just taken it to 3 decimal places so that it's to the closest meter. So I'm going to write that on my diagram as well. So I've got 8.567 kilometers in that direction. Alright, last thing that I want to do is I want to find out the bearing required to return to the harbour. So if I go back to my drawing, I'm currently at the island. What I want to do is I want to find out the bearing to get back to the harbour. So I'm starting here, so starting from north, I want to find the angle from here all the way around up into the blue line, which is the direction that I travel. So I know it's 90 degrees here, another 90, another 90 up to this point, so it's 270 degrees up to here. What I need to do is find this angle here and add it to the 270, and that will tell me the full bearing from here all the way around. Now hopefully you can see the Z. Are you getting used to it? So you can get the Z from here going down and across, which means that this angle is the same as this angle that we used up here. So this guy there is 50 degrees. So the bearing is going to be 270 degrees plus the 50 degrees, which is going to give me a bearing of 320 degrees to go back home. So the bearing required, it's going to be 320 degrees. That's my bearing. Anyway, thanks for watching. I'll make another video on some more difficult ones. Please subscribe, and I'll catch you next time.